Certainly. While for loops are a fundamental part of Python, there are often more efficient and Pythonic ways to achieve the same result without explicitly using them. This can lead to cleaner and more readable code, as well as potential performance improvements. Below are some alternatives to for loops, along with explanations and examples. Using list comprehensions provide a concise way to create lists. The syntax is generally more compact than using a loop, and it's often faster as well. Example: squaring numbers instead of using a for loop. Python squared numbers for I in range 10 squared numbers. Append I to print squared numbers. You can use a list comprehension. Python squared numbers I2 for I in range 10 print squared numbers. 2. Using map. The map function applies a function to every item in an iterable like a list and returns a map object which can be converted to a list. Example: converting strings to integers using a for loop. Python numbers through on 2. 3. For numbers for number in numbers str numbers append int number print numbers using map. Python numbers str on 2. 3. For numbers list map int numbers str print numbers. 3. Using filter. The filter function constructs an iterator from elements of an iterable for which a function returns true. Example: filtering even numbers using a for loop. Python numbers range 10 even numbers for number in numbers if number to 0 even numbers append number print even numbers using filter. Python numbers range 10 even numbers list filter lambda x to 0 numbers print even numbers. 4. Using NumPy for array operations. When working with numerical data, the NumPy library allows for operations on entire arrays without explicit loops, which can be significantly faster. Example: adding to arrays using a for loop. Python import NumPy as and pimp array 1, 2, 3 bamp array 4, 5, 6 result in zeros like a for I in range len a result I by print result using NumPy array operations. Python import NumPy as sound pimp array 1, 2, 3 bamp array 4, 5, 6 the result of vectorized operation print result. 5. Using generators. Generators provide a way to iterate over data without creating a complete list in memory. They yield items one by one and can be more memory efficient than using lists. Example: yielding squares using a for loop. Python def generates squares and squares for I in range of z squares. Append I to return squares. Print generate squares 10 using a generator. Python def generate squares in for I in range yield I to print list generate squares 10. Conclusion: while for loops are useful and sometimes necessary, Python provides a variety of alternatives. By leveraging list comprehensions, map, filter, NumPy, and generators, you can often achieve the same results in a more efficient and Pythonic manner. Always consider the context of your problem and the readability of your code when deciding whether to use a loop or an alternative approach.